Last topic we have to discuss this unit is something called intermolecular forces, also known as IMFs. We're going to start by breaking the term down into its two parts. The prefix inter means between, and molecular means what it sounds like, molecules. So intermolecular forces are interactions between individual molecules, like one water molecule interacting with another water molecule, as opposed to bonds, which we would say are intramolecular. Intra meaning, I don't have a whole lot of room here, but within the molecules. In other words, bonds are the forces within the molecule holding the atoms together. Intermolecular forces, or IMFs, are interactions between molecules, and they're much, much weaker. Bonds are very strong. The forces that hold hydrogen to oxygen within a water molecule are very, very strong. And that's why it takes a lot more energy to split a water molecule than it does to boil water. Boiling water means overcoming IMFs, or intermolecular forces, the weak forces that occur between molecules of water. The other thing I want to just mention here and make sure that we understand is that the molecular part of IMFs means that we are only talking about covalent compounds, never ionic compounds. The idea is that in ionic substances, the bonding is network, meaning it's just alternating positive, negative, positive, negative, positive, negative, and there are no individual molecules. You can't have intermolecular forces if you don't have molecules. So the concept of IMFs only exists in covalent compounds. I mentioned before at the start of this, they're weak forces in comparison to bonds. Bonds are very strong. IMFs are very weak. And one of the IMFs we're going to talk about is actually called a hydrogen bond, and you got to make sure that you keep that straight. It's a terrible name. It's not technically a bond. So these IMFs occur between molecules. They hold molecules to one another. And we only worry about IMFs in the gas and liquid states. And we talk about moving from solid to liquid to gas and overcoming IMFs in order to do it. But where they become measurable are in the liquid and gaseous state, because now the molecules are moving around. Mention again that they're weak forces, and that's in comparison to chemical bonds. This is huge. It's very important that you understand that IMFs, the interactions between individual molecules, are extremely weak. They don't even compare to the forces that hold the atoms together, the bonds that hold the atoms together within the molecule. If I haven't made it clear, here we are in bold. Go ahead and circle that 3 or 4 times. IMFs, intermolecular, occur within a molecule. Bonds, or between molecules, bonds occur within molecules. Inter, between, intra, bonding, is within. Now, just a quick illustration here. Last couple pages we talked about this being a polar covalent bond. We look at the electronegativities. That difference in electronegativities results in a partial positive and a partial negative. You have the same exact thing going on here in a neighboring molecule. Generates a partial positive, partial negative. Because these molecules are both polar and have partial and negative charges, that's why this little interaction occurs. The partial positive is attracted to the partial negative, and vice versa. So these molecules will kind of stick together just temporarily. Right? And hopefully it's apparent, since they're not actually sharing electrons, right? The molecules aren't really sharing electrons. This is a very temporary interaction. It's there and it's gone. The stronger the interaction, the higher the melting point and boiling point. So something with very strong IMFs will have a higher melting point and boiling point than something with very weak IMFs. Give you a specific example, an illustration, an animation. We'll take a look at this. This is how water, we'll use water to demonstrate the concept of IMFs. They show you the partial charges, slight positive, slight negative. And then when we introduce additional waters with our romantic mystery music, I'm not sure where this comes from, but we now see the connections being made, these temporary fleeting connections between individual molecules. And these things would, like I said, they're going to break and reform billions of times in just seconds. All right, so these interactions are very weak and they're very temporary. Again, I might as well put a couple stars here. If we haven't made the point yet, one last time, a reminder that IMFs are not bonds. So there are three particular kinds of IMFs which we are about to cover. And you need to make sure you never confuse them with bonds, and never, that you always remember that they don't compare at all with the strength of an actual chemical bond.